Okay, we'll start with Ampere Circuital Law. Right, Ampere Circuital Law. Ampere circuit and then circuital law. Right. The law is very simple. It is just this. B dot dl is equal to mu naught times I. Right? Now what is this symbol? This symbol is of integral, and this symbol is of line integral. Okay, line integral. So what is the meaning of line integral? The meaning of line integral is that you integrate something along a line. Okay, you will integrate something along a line. So for example, line integral is a fancy way of saying this. Yeah, suppose this is a rectangle, this length is L, B. If you know, if you go around like this, this path. Yeah, if you go around like this path, okay, like this, one loop if you cover, you are going to get a perimeter of 2 times L plus B, right? So, so this is just a fancy way of saying line integral of length is 2 times L plus B. Okay, fine. Or I'll give you another suppose example. For example, suppose there is some field, electric field or magnetic field or any field. Okay, suppose there is a red color field and it is going like this. It is going like this. Okay, from right to left. Fine. It's going from right to left, and suppose its unit value is some 50. Okay, some units, I don't care what units. Okay, 50. If it's magnetic field, it's Tesla. If it's electric field, it's Newton per Coulomb. If it's some other field, gravitational field, it's just G. Okay, fine, whatever. Now, if you place a loop, it's a different loop. Okay, there is a loop, rectangular loop, which is like this. Okay, इसका length L है, breadth B है, और ये loop है A, B, C, D. Okay, so what is the line integral? Line integral, suppose this जो field है ये F है, ठीक है, F vector is 50. So line integral of F dot dl, ठीक है, F dot dl is equal to, ये जो dl है ना, dl, this is the dl is the circular, इस loop का है, dl is of the loop which you have placed along the length in which you are integrating. Okay. And the F is the field. Dot product means dot product of the field and the length vector. So suppose if you go from B to C, if you go from B to C, if you go from B to C, then you will see that along the length, the length vector is like this. Okay, the dl vector is like this from B to C. Fine, from B to C, and the F vector is also like this. Fine. Okay, so what is the dot product between them? Dot, how will dot open? What is dot? Dot मतलब क्या होगा? Guys, please answer. FDL cos theta. What is the angle between them? From B to C? 0, right? So cos 0 is 1. So it will be just F dot dl, FDL. Okay. So from B to C, this vector opens up as F ka value 50 and integral dl kitna? Integral dl is just from B to C length. What is the length of this? L, right? Yes or no? 50 into L. And of course cos 0. Integral dl समझ में आया? Integral dl is what? It is the length of the line. Okay, loop. Okay.
Yes, sir.
So 50L plus 50L minus 50L plus 50L, right? Because cos 0 is 1. Okay. Acha. Now from C to D, it will open up like this. C to D, what is the length? What is the direction of F? F to ऐसे ही है. F to ऐसे ही है, right? Red color. Or length vector is DL vector is like this everywhere from C to D. Yes or no? Are these perpendicular?
Yes, sir.
So cos 90 कितना हुआ? 0.
0.
From C to D, the integral F dot DL is 0. Understood? Everyone understood this?
Yes, sir.
Yes, sir.
From D to A, the field vector is like this and the DL vector is like this. So the angle between them is
180.
and cos 180 is
Minus 1.
minus 1. So the answer of FDL here is minus 50 into L, because F is 50 and the length is L, right? Yes or no? समझ में आ गया? Okay, and again from A to B, I don't need to explain this again. F dot DL is 0. Yes or no?
Yes, sir.
Everyone got it?
Sir.
Yes.
Sir, what is that red arrows in blue?
Both. Yeah, one second. Are you talking of these arrows?
No, in the the rectangle ABCD over there. You mean
The red line is the field line. There is some field. Okay.
okay,
Whose magnitude is 50 units.
okay, fine.
And the black is the loop which you are considering, on which you are doing this line integral. Okay.
Okay.
So जो line integral है, वो it is not, वो field का नहीं होता, ठीक है? Only field का नहीं होता, वो field का किसी loop पे होता है. सिर्फ ऐसे नहीं होगा कि I will ask you one second. I can't ask you what is the line integral of this red field, magnetic field. No, I will have to ask you what is the line integral of this field over this loop. Okay. So is that fine? Is this fine with everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So what is the Ampere Circuital Law? ये था ना, सबने लिखना है integral B dl is mu naught n. Okay. So the Ampere Circuital Law states, right? It states that the line integral of magnetic field over a loop, the line integral of magnetic field over a loop is equal to mu naught times the current crossing that loop. Just make that included sign that inverted V before the current and write net current. So I'll explain. I'll write again. I'll say again. The line integral of magnetic field over a loop is equal to the net current passing through that loop. Okay. Fine. So let us. Okay, this loop is called an Amperion loop. Saksham, you turn on your video. Okay. This loop is called an Amperion loop, right? Okay. Everyone has copied this. Now, okay, let us इसको ना we'll apply this law. Okay, apply this law. So this law is just like, see this, ये जो Ampere Circuital Law है ना, this is exactly like not same but similar to Gauss's law था electrostatics में. You remember integral B dot ds is mu naught. I think no, it was integral B or E dot ds is Q enclosed by epsilon naught. The surface integral था वहाँ पे. The surface integral of electric field is equal to the charge enclosed by the epsilon naught, right? So it is similar to that. So see, we have already found out this result. This result was एक result हमने निकाला था कि there is a straight electric field, straight current carrying wire of current I. Then the magnetic field at a distance r from this, कितना होता है? Magnetic field at this distance r कितना होता है?
Not by
बोलो.
then you not by 4 pi ideal by ours.
Mu naught by 4 pi थोड़ी ना होगा. Mu naught by ये गलत है थोड़ा. Mu naught by 4 pi.
So ideal by ours.
Ideal by r. ये तो नहीं ये तो Biot-Savart law तो you are trying to say.
Okay. Sorry.
We used Biot-Savart law integrated to find magnetic field no at this point from infinite wire. वो result पूछ
Oh,
रहा
that
हूँ.
one.
हाँ. Go back and see.
Then you not I by 2 pi that one.
2 pi है. सर्कल में pi नहीं होना चाहिए. नहीं सर्कल में pi नहीं सही है. वो फिर से बोलो.
You not I by 2 pi r.
Yes, ये है. Yes. So do you guys remember ये कैसे आया? How did we arrive at this result? Do you guys remember how did we arrive at this result?
We integrated it in that, right?
Yeah, and एक बड़ा सा integration था ना? You
Yes,
know, we did alpha with house में, right?
Yes, sir.
Alpha, and then there was an expression of sine alpha plus sine beta, right?
Yes.
So, no. And then finally we put alpha and beta both 90, and then we arrive at this result. बड़ा सा integration था. So it is similar to. Do you remember in electrostatics I asked you what is the electric field at a, if there is a uniform charge carrying rod of charge density lambda, linear charge density lambda, and then we arrived at a result of what is the electric field at distance r. The electric field was lambda by 2 pi epsilon naught r, something like that, right?
Yes.
You guys remember? And usme bhi we integrated, right? First we have done by integration, and then we have done by Gauss's law. Gauss's law may we take a symmetry cylinder, and then so by 3-4 arguments we can find the electric field instead of integrating, right? Remember these things?
Yes, sir. Yes.
You revise, okay. So same way here also what we can do is we can find the result using Gauss's law. So पहले के देखो Gauss's law कैसे apply करेंगे. First, we have to think of an Amperion loop, okay, along which we will integrate. So, Amperion loop, see, there is a B and DL, right? So, the magnetic field is how, do you know the nature of magnetic field? That is very obvious. 10th class से पता है कैसी होती है. How is it magnetic field around ये current carrying wire है कैसी होती है इसके around? Concentric circle ऐसे होती है ना, ऐसे you take this wire and it goes on like this, right?
Yes.
Right? So the magnetic field will be like this, center concentric. Okay, and then another big circle, right? Yes or no? सही है?
Yes, sir.
Correct. Okay. What are some observations about this? The observations about, see, this is an infinite wire, right? So some observations are, if there are 2 points at a distance, same distance from the wire, if there are 2 points at same distance from the wire, okay, RR, P and Q, the magnetic field has to be same at both points, right? Because it's an infinite wire. There is nothing ऐसा कोई P और Q में special point नहीं है. मतलब P is also in between the wire somewhere. Q is also in between the wire somewhere, right? So if so, BP is equal to BQ, right? Why? Because if the R is same, R is same. Okay. Okay. First point of observation. Second point of observation क्या है? कि if Q यहाँ भी होता ना, यहाँ पे उल्टी साइड, यहाँ पे उल्टी साइड, लेफ्ट साइड, but at the same distance R, or it could have been इधर पे, but at the same distance R. The direction of magnetic field will be different, but the magnitude will be same, right? So I'll write Q double dash B Q mod. I'm not writing magnetic field. I'm writing magnitude of magnetic field is equal to B Q dash mod is equal to B Q double dash mod. Although here I'm not putting any mod because here the direction of magnetic field is also same. Do you understand this, everyone? यहाँ mod है, समझ में आ गया ना? So everyone got it?
Yes, sir.
Yes. So then you can guess कि if there is some magnetic field, suppose BP पे is point P पे, the magnitude of BP is some fixed quantity, suppose F naught or B naught. If you fixed quantity है B naught, some quantity. ये B naught और कहाँ होगी? Where will this B naught? Where at all, which all points the magnetic field, the magnitude of magnetic field is same? Do you understand my question, everyone?
Yes, sir.
Sir, in that particular same circle.
Okay. Yeah.
First, पहले तो पहला same circle पे same है, right? ये सबको समझ में circle पे पक्का same है, right? Hello, yeah, guys, yeah, circle पे same है, fine. Circle पे same है, तो मैं वो circle highlight कर देता हूँ जिसपे same magnetic field है. Circle पे same है, right? और कहाँ same है? और कहाँ सेम है? बेटा ये भी तो देखा था ना, क्यू पे सेम है, राइट? तो ये
Yes.
ऑल दीस पॉइंट्स पे भी तो सेम है.
Yeah, so line parallel.
तो फिर तो ये वैसे सेम है ना, सिलेंडर पे सेम है ना पूरे?
Yeah.
पूरे सिलेंडर पे सेम है, राइट? Yes or no? Basically what I'm trying to say is that if I make a cylinder of radius r, okay, around this cylinder है, ठीक है, radius r का, at every point on the circumference of the cylinder, at every point on the circumference of that cylinder, B is same. हर पॉइंट पे, यहाँ पे यहाँ पे इसके circumference पे जो भी पॉइंट है उस पे the magnetic field is same. Okay, if someone is watching this from here, okay, from here if someone is watching ऊपर से top view, okay, then what he will see, if top view देखो, top view से दिखेगा, top view, that the current is coming towards you, okay, it is like coming out of the plane, okay, and there is a magnetic field SE point P and the magnetic field is like this. Yes or no?
Yes.
Yes. Okay. ये समझ में आ गया?
Yes,
Everyone
sir.
got it?
Yes, sir.
Yeah,
Now.
so
Now on this loop, at any point if I ask you magnetic field कैसी है, तुम बोलोगे इस point में magnetic field ऐसी है, right? Yes or no?
Yes, sir.
Tangent है ना, tangent है every point पे. Yes or no? किसी को डाउट है इसमें? नहीं ना, पक्का? क्यों है रूपक tangent? Why it is tangent?
because it'll pass, it won't touch the circular and it'll just move straight.
Because it is circular lines.
Yeah. Okay.
Okay. So therefore, if you take at any point, so suppose then what I'll do, magnetic field is my red, ऐसा red पूरा होगा, right? Magnetic field is like this, no? Magnetic field line. I will take the Amperion loop also the same. Amperion loop also same, okay? Then what will happen? if you take any part of the small part of the Amperion loop, okay, suppose ये dl part लिया, इस dl का direction कैसा है? It is like this. Yes or no? If you take a circle, the tangent is the direction of that part, right? If you take a part of that circle. और यहाँ पे magnetic field भी कैसी है? ऐसी ही है. Right? So the line integral of b dl. Right? अब किसी भी point पे, see, at this point it is b dl, right? At the next point तुम दूसरा लोगे, suppose dx ले लिया, ये length dx ले लिया, तो यहाँ पे भी b dx है, right? Plus b dx, right? The magnitude is same. It is not b1 b2, right? It is same b b. ठीक है? प्लस दूसरा आगे थोड़ा सा पार्ट लूंगा, तो सपोज dt ले du ले लिया, du डिस्टेंस, अब इंटीग्रल b du. अब ये देखो, ये b बाहर निकलेगा, b will come outside because it is a same constant, right? It is like integral 5 dx is 5 integral dx. Okay, तो ये b निकला, फिर क्या है? dl plus dx plus du, ये whatever small length. अब ये बेटा ये सारे इसको ऐड करोगे, what is this integral? Fun integration का sum
2 pi r.
2 pi r, right? It is the circumference, so it is b into 2 pi r. Okay, this is the line integral. Now this must be, according to Ampere Circuital Law, this must be equal to mu naught times. अब देखो तुम्हारा लूप कौन सा है? ये लूप है ना, ग्रीन वाला, right? Mu naught times the current, net current passing through the loop. इस लूप को कौन सा करंट काट रहा है? Which current is cutting? ये लूप है, right? लूप करंट ये काट रहा है, right? ऐसे guys, right? How much current is that? That is I.
I.
बस mu naught I. हो गया, एक लाइन में आ गया. क्या आंसर है? B is equal to mu naught I by 2 pi. ओके, सेम रिजल्ट जो ऊपर था ना, यहाँ पे लिखा mu naught I by 2 pi r, वो भी नीचे भी आ गया. फाइन. Okay, everyone, you understood how Ampere Circuital Law works?
Yes.
Okay. Okay, so read example 4.8. I'm sending the PDF in the group chat, in the Zoom chat. Read example 4.8, okay? It is NCERT book ka example. This is example of NCERT book, okay? And yeah, it is on page number 18 of the PDF.
So I didn't get the part where the yeah, the second part when they're finding out the current.
Hmm.
Why are they like dividing pi r square by pi square?
Because if the current is uniformly distributed over this whole cross section area,
Yes.
and then when you're taking a Ampere circuital loop at a distance r, at some distance r between 0 and a, between the radius of that Ampere circuital loop is between 0 and a, okay, then from that circuital loop the whole current is not passing.
Yeah.
Proportionately less part of that current is passing.
Yes.
So that's why how much proportionately less is equal to
Okay.
the fraction of the area that is covered within that into the total current. So okay, I hope okay. So see, if you don't understand, you ask me again, okay? Guys, have you understood the example 4.8?
Yes, sir.
Yes, sir.
Yes, sir.
Anushka, can you explain the first part of that? Anushka, can you explain the
Yes,
first
sir.
part of that?
Yes, sir. So the first part is when R is bigger than A. So it's the loop that's outside. The length of it is 2 pi r, which is the perimeter. And the current is the current that's going through the wire because it's enclosed around it. So then using Ampere's circuital law, they got B is equal to mu naught I by 2 pi r.
Okay, so and Rochelle, you explain the second part of the question.
So in the part where there's small circle which is 1, only the magnetic field is mu naught I by 2 pi a, and then the current enclosed in the bigger part is I. The total current enclosed in bigger part is I equals to the total part in the first the bigger sphere minus the smallest sphere. Sorry, not minus, divided by.
Okay, so if you have understood this problem, everyone has understood. So I have sent a question in the Zoom chat. You do and send me a photograph of the solution.
So do we have to send you the solution?
Pardon?
Do we have to send you the solution?
Yes. Two is to 1.
Yes. Is it 8x or 8?
गलत 8x और x by 4 है. तुम दोनों में सेम फॉर्मूला यूज कर रहे हो क्या? दोनों में सेम फॉर्मूला कैसे है? एक अंदर है रेडियस के, एक बाहर है रेडियस के.
Oh yeah. So for the outer one, I have to use the normal one, and the for the x by 4, the
Yeah.
area one.
Yes. For x by 4 you have to use 4.19b in your example, and for outside one you have to use 4.19a. Yes, guys, send me answers. Section you have not sent again. What is the ratio? Ratio nikalo, Anushka.
Oh, yes, yes.
The formula which you put is you got ix cubed at the. How are you getting that? Square. The formula is mu naught IE is I into pi I x raised to 4 by 16. That's correct. Then you are getting mu naught b into 2 pi x is equal to mu naught I. ये कैसे कर दिया? Mu naught I x raised to 4 by 16 के सो अच्छा सही है, ये तो x cube सही है. Magnetic field at 8x. 8x mu naught I by I. गलत है. I into pi x by 4 by whole square. हाँ ये गलत है. You have done that wrong. That Anushka, that
Yes, sir.
X, the first line is wrong. There should not be any x raised to 4. It will just I by 16. Because x raised to square will get cut.
Oh,
For the second part is I, like for the smaller one, when it's x by 4, is the I by 16 or 16i?
First part में I by 6 कम होगा ना? To take a smaller radius, it will be lesser, I by 16.
So, sir, will it be like I times of pi x square by pi x by 4 the whole square? Like in the example, it was given I times pi r square by pi.
One second. Anushka, you just edit your thing and send me again, okay?
yes, sir.
Fast, do it fast. So 1 by 256.
Yes, sir, that's what I'm looking.
1 by 256.
Yeah.
Yes, sir. Yeah.
8x. Why are you doing all that 8x pay? Why are you doing I square? What? 8x pay. What is the current? It is same I. I will not increase.
Yeah. No, not only 8x, x by 4.
X by 4 पे तो ठीक I by 16.
No, I'm getting 16 now.
कैसे 16 आई? मतलब क्या?
Because
16.
Current कितना है? Just passing through X by 4.
no, sir, see, the example you were like we just saw here in the second part, like it was given that when R is less than A, so it taking the current as I times pi R square by pi A square, right?
Which is I R square by A square.
Yeah.
इसमें what is the radius? मतलब what is the radius up to which you are taking?
X, and the A, like the which is for the second one, it's x by 4.
So X by 4 इसमें if you compare A क्या है? AX है कि AX by 4 है?
Shouldn't it? Okay. Wait, I'm confused. So then we should take x by 4 in the first one and 8x in the second one. Because in the example it was given when R is greater than A.
R क्या होता है?
Which is the given radius, like the original.
It's not the given radius. ठीक से बोलो तो सही होगा.
The
What is
original radius.
No, it is not the original radius as well.
R is the smaller radius.
R is the radius up to which you are taking the Gaussian loop.
Yeah.
R is the radius of the Amperion loop.
Yes.
And what is A? A क्या है?
Is A the radius of the circle?
Wire का radius.
Okay, so even I did the same mistake.
I got it.
फिर गलत कर दिया. वो I by 16 है. Mu not I B into 2 pi.
I wasn't.
गलत
I
है.
didn't put the x. I didn't put the x.
वो लेफ्ट साइड में गलत है तुम्हारा. X by 4 होगा.
Yeah.
B into 2 pi x क्यों है? It should not be B into 2 pi x. It should be Ampere Circuital Law is for which radius? It is X by 4, no?
Yeah, I didn't put x. Oh, it's x by 4.
Edit it again and send. Kushal? नहीं हो रहा.
to it.
Or is it 2:1?
So can you tell the answer for the x/4 one? X/4.
Can you tell the answer for the
X/4 one.
Anushka? Send your edited answer to the group. Okay.
Yes, sir.
Or I sent.
Anushka, you also get some 1:2 or 2:1.
Yes, sir.
Let
I'm
me
getting
write
1:2.
Yeah. 2:1 or 1:2? You have to find for x/4
No,
is to
I'm
8x.
yeah, I'm getting 2:1.
Okay. Send it
Oh.
ASAP in the group.
So I sent it.
Everyone see, this is the correct answer. Okay. And so I have sent one more question in the Zoom chat. Oh, I have not. Now I have. Oh no, 1 second. It's not copy paste. It's not doing having copy paste. 1 second. Right, a wire carrying a certain wire carrying certain current produces a magnetic field of 0.8 Tesla at a distance 0.5 centimeter. So at 0.5 centimeter, it's 0.8 Tesla. Okay. What is the magnetic field at 1 centimeter?
So can you repeat the values?
At 0.5 centimeter, it's 0.8 Tesla. What is the magnetic field at distance of 1 centimeter? इसमें the wire is not thick, okay, so it is plain simple है पतला सा.
Sorry, sir, can you repeat the question?
The magnetic field at a distance of 0.5 centimeter is 0.8 Tesla from a straight wire. 0.5 centimeter is 0.8 Tesla. What is the magnetic field at 1 centimeter?
That is at 0.4.
Are you sure?
I mean, it's the same wire, right?
Yeah, it's same wire.
Yeah.
Magnetic field varies as 1 by R or 1 by R square?
Yeah, so is it 0.4?
1 by R.
0.4. So it's 0.4. Okay. Everyone got that is 0.4 Tesla? Hello? Everyone got that it is 0.4 Tesla? Yes or no?
Yes.
Yes, sir.
Anushka, Aditi.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now my question to Aditi is Ampere's law relates which two quantities?
Radius of the circle and current.
No. No.
Sir, I'm not sure. Like magnetic field in relation with the radius.
It relates, right? It relates magnetic field and current. Ampere law relates magnetic field and current. Okay. Yeah. Okay. So this is about Ampere Circuital Law. Then we'll do magnetic field due to a solenoid. Okay, solenoid. So right, magnetic field due to a solenoid. So what is a solenoid? Solenoid is basically many turns, closely turns on a cylindrical or cylindrical surface. Yeah. So there are tons. So there are some things parameters in a solenoid. Solenoid parameters are n is the number of turns per unit, length, number of turns per unit length. Okay, that is n, and I is the current in one part. Okay, so there is if you see the magnetic field due to a part of the wire, if the wire is going like this, the magnetic field is like this, no? It will be like this, yeah, around the wire, right? Yes or no?
Yes, sir.
Okay. Open your books and see. Open your books and see this figure 4.17. Okay, figure 4.17. I have already sent you the PDF of the book, so you can see the figure 4.17. It's a solenoid photo. I'll share my screen. See this? Yeah, can you see this diagram? I am also sharing my screen. So you zoom in and see how is the magnetic field. Zoom in and see how is the magnetic field due to these small, the current carrying wire. See, magnetic field is. See here that the yeah, see here. This is the wire. Okay, this is the wire. It is going. Okay, this is the wire. It is going. At this point of the wire, the magnetic field is like this. Circle. Okay, fine. And then due to this, there is a circle here, circle here. Okay. Now see, if you want to find the so what will happen? See, if all these circles get added up at a point, at suppose this point, okay, this point, the magnetic field is also due to this part of the wire, also due to this part of the wire, some weak due to this part of the wire also, right? Yes or no? Guys.
Yes, sir.
Okay.
So when you add these quantities, the final result is that, right? The magnetic field inside the solenoid, is almost uniform. And magnetic field just outside the solenoid, मतलब जो Q point पे magnetic field होगी वो 0 होती है. Okay, Q just outside जो होती है वो almost negligible होती है. Fine, everyone. And you make both of these diagrams A and B. Make both of these diagrams A and B.
So at Q it is 0.
Pardon?
So where is it 0?
Q just outside, मतलब यहाँ देखो जो outside point है ना, देखो मैं solenoid दिखाता हूँ कोई. हाँ, इसमें ये solenoid है, right? इसमें solenoid में the turns are like this. Okay. 1 second. I'll first तुम बना लो फिर बताता हूँ. पहले इसको बना.
Okay.
A B बना लो पहले और फिर नीचे वाला भी बनाना. Done? Have made this diagram, everyone?
Yes, sir.
Yes, sir.
Next is you make this diagram quickly, okay? Then we'll talk of this diagram. And yeah, make this quickly. Okay, see, so the section here, have you understood that where the magnetic field is 0 and where it is uniform? Inside the solenoid, it is uniform.
Yes.
Outside, just outside the point, it is
0.
it is 0. So what we do is you make this. Have you made this made this triangle? This triangle is the Amperion loop. Okay, this triangle is the Amperion loop. Okay, sorry, rectangle. This rectangle. Okay, and if you see, there are 4 sides to this rectangle. Okay, A, B, C, D. The AB side is fully inside it, and in the AB side, Aditi, you tell me the length vector is in which direction?
Right to left.
Right. Length vector left to right.
Sorry, left to right. Yeah, left to right.
Field
Field is also left to right.
left to right. Okay. So if you do integral BDL of this, you will get the length is h, right? उसका h है ना, length AB दिख रहा है ना, ऊपर length है.
Yes, sir.
And if the inside magnetic field is uniform, तो B into h, right? Hello.
Yes, sir. Yeah.
B into h, yes or no?
Yes, sir.
Aditi, I am asking Aditi only.
Oh, yes, sir.
Okay. In the part B to C, okay, till the red point, from D to till the red point, there is magnetic field, right?
Yes, sir.
In which direction is it?
From left to right.
Okay. In which direction is the DL vector?
Left to right.
DL vector. It is along the length of the line. Is it along the length of the loop?
So right to left.
Oh. The loop is from B to C. The loop is like this, no?
Oh, like that. Yes, sir.
So it is in which direction? The loop is in which direction?
Oh. So 1 second.
North. Or
Yeah,
up.
not. Okay, I thought you were talking about like the magnetic field around it.
Magnetic field is in which direction?
Clockwise.
No. The clockwise magnetic field that is already done. The magnetic field in this diagram is to the right. That's it. That's the only magnetic field.
Yes, sir.
So what is the line integral BDL in this part from D till red point?
So can you repeat the question?
What is the line integral of D from in the black portion?
Oh, it's the formula thing.
Yeah.
Oh,
What is the direction? Again, I'm asking. What is the direction of D?
north.
D magnetic field.
So
There is only one magnetic field.
yes, sir.
वो बना हुआ है, क्या बना है? देखो डायग्राम में.
Oh, sir, I'm not sure.
And therefore the solenoid is like this. Okay, ऐसे पूरा looping है. The magnetic field is like this, right? And the loop is like this. A, B, C, D. From A to B, the magnetic field is like this, length is like this. So if the length is L, total length is L, so the line integral is B dot dl, it is B into L. Okay. From B to from in the loop B to C, in this portion, from B to X, what is happening? B is like this and L is like this. So they are perpendicular. So the line integral is 0, and from X to C, the B itself is 0. So in either of these cases, the integral BDL is 0. Do you understand this or not?
Yes, sir.
Everyone?
Yes, sir. Yeah.
Anushka?
Yes, sir.
From C to D, the magnetic field is 0. So therefore BDL is 0. Okay. Integral BDL is 0. And from D to A, again the same thing like this. That is from D to Y it is 0 because, Anushka, tell me why from D to Y it is 0?
Because there is no magnetic field there.
Yeah, and
So
from Y to A, why it is 0?
because of the angle between.
Yes. So what is the net कितना है? बस यहीं पे था ना नॉन जीरो, इस वाले में नॉन जीरो था, which was BL, right?
Yes,
So
sir.
BL is equal to mu naught times the current enclosed by this loop. Okay, अब देखो इस loop में, in this Ampere loop, how much current is passing? वो निकालेंगे ऐसे that you know, see, there are wires which are going like this, right? ऐसे, which are going into the cutting the current in the loop. So if the length of this loop is L and the number of turns per unit length is N, so the number of loops which are passing, number of loops कितने हैं? NL, right? Yes or no?
Yes, sir.
And each is having current I, so the net current is NLI. So it is NLI. Understood? The amount of current passing through this loop, Ampere loop, is NLI. Why NLI? NL is the number of turns which are passing through this loop, which are in this loop, and I is current in each. Okay.
Yes, sir.
So therefore, LL will go from both sides. You will get B is equal to mu naught NI. Okay, where N is the number of turns per unit length and I is the current. So and B is the magnetic field. That's why magnetic field is mu naught times NI.
Sorry, I got disconnected. Can you explain how you got like mu naught NLI?
Pardon?
So can you explain again how you got mu naught NLI?
Not NLI. So the right, did you understand the left side का integral is dl?
Yes, sir.
The right side है कि वो जो Amperion loop है, Amperion loop is the rectangular black colored loop. Okay.
Yes.
Black color loop से ऐसे, so if this is my solenoid, उसके पास ऐसे से they are wound, right?
Yes, yes, sir.
So I have taken a rectangle which is like this, okay, on this.
Yeah.
अभी
Yes, yes.
इसके थ्रू कितने लूप्स पास करेंगे? जितना कार्ड का लेंथ है, right?
Yeah.
Into the
Correct.
into the number of turns per inch.
Yeah. Okay.
That is the number of
got it.
turns into I. Okay.
Yes.